Okay, next up is 10-2, simplifying radicals. So this is kind of a general example of what the radicals are going to look like today. You're going to have some stuff on the outside, a radical sign, and a whole slew of stuff underneath. And our goal is to take out any squares that we can so that there's no square numbers or variables or anything underneath the radical sign. So the first thing that's important for you to know is that the radical sign can kind of be distributed to everything underneath the radical sign. So for example, for a moment, just ignore this 3y cubed out here. It's just going to hang out. But I can take this, instead of being the square root of all this stuff, I can turn it into the square root of 27, the square root of x cubed, and the square root of y squared. And that's helpful because now it's easy for me to see how I have the square root of a number squared? Your square root and your square cancel. So now this y is on the outside. So it gets to come over here with this y, which eventually we'll remember that, oh, we can combine those and that's just going to be 3y to the 4th. So if I fill in where I was up here. So what I'm going to do next is maybe try this 27 and think, okay, what are two numbers that multiply to 27, specifically using square numbers? So over here on this column, I'm going to find the biggest square number that divides into 27. And it looks like that number is going to be 9, because 9 times 3 is 27. Okay, and that's helpful because, hey, what is the square root of 9? Well, that's just a nice, happy 3. Still stuck with that square root of 3 because that's not a nice, easy square root. Now, the x cubed is a little harder. Here's the long way and the mathematically correct of explaining way this. If I recognize that this is all just multipliers, then I say, well, isn't x cubed just x times x times x, all under the radical sign? And if I can be picky on how I combine them, that would just be the square root of x squared times the square root of x. And again, those squareds cancel. So I have x times the square root of x. Kind of a way you can shortcut that is to look at the 3 and say, okay, what's the biggest number less than 3 that is evenly divisible by 2? Since remember the imaginary index on this would be 2. Think back to chapter 7. And it would be the biggest number less than 3 that's divisible by 2 would be 2. How many are left over? 1. There's an imaginary exponent there. We'll do more examples of that, but that's how you do that. So what you're left with then on this row is 3y to the 4th times this 3 times the square root of 3 times x times the square root of x. Take all the stuff that's on the outside and combine it together. So like I have this 3 times this 3. That would be 9. I'm going to go ahead and move the x over along with the y to the 4th. Did that take care of everything on the outside, it looks like? And then combine everything that was in the radical sign, so that would be 3x. That is my super duper complicated answer, but it's actually the simplified answer. So let's do another problem. So we'll try this one next. Again, try to find the biggest number that divides into 150 that is a nice happy square number. So this time I think the number is going to be 25 because 25 times 6 is 150. And each of those can have their own square root. And hey, the square root of 25 is 5. And don't forget this 3x needs to come down with all this. So 3x times this 5 so far. And I have a square root of 6. Now 7, I'm dividing by 2, right, because it's a square root. So the biggest number smaller than 7 that's evenly divisible by 2 would be 6. So I should have x to the 6th And to get that extra to the 7th is 1. Okay, and if you're lost on how am I getting those numbers, go back to chapter 7. When you have exponents being the bases multiplied together, you add them. So 6 plus 1 is where I get that 7. Now do the same thing with the y. The biggest number smaller than 5 that's evenly divisible by 2 is 4. 4 plus what is 5? It would be 1. Okay, and what you're doing is you're just taking these exponents and dividing them by 2. So 6 divided by 2 is x cubed. And y to the 4th divided by 2 is y squared. You just have an xy left over. Combine the stuff on the outside here. So 3 times 5 is 15. X times x cubed is x to the 4th. And that's just a nice happy y squared. And that is my final answer. Hey, make sure that you check out on your Delta Math this time. He does have a video for this one, so make sure you check that out for extra help, okay? Right here where it says watch help video. He gives you more hints and help and success to do this.